Okay, we'll get started in maybe a minute or two, just letting people join that need a couple minutes to join. I will be sharing my screen and we'll get going. This functions both as a seminar for parents of children. This is a mirror presentation of a presentation that I gave at a Pittsburgh local gathering of multiple school districts, superintendents. And then this will also function as my November monthly update since I was not able to post one because of the holidays. And this will be recorded so that people can see it afterwards, as I know quite a few people said that they couldn't make the live timing, but this will be recorded and we'll take questions if there are questions. Okay, so I have my presentation up. I actually can't see the comments or the Q&A or even who's joining at this point since I have my presentation on presentation mode. I know that my colleague Adi, who normally joins these, he's out of the country for business actually, so he will not be able to monitor the Q&A during the presentation, but this should be a pretty quick presentation in itself, and then at the end, when I minimize my presentation screen, then I'll take any questions as there are questions or if there are questions at that time. So this presentation is entitled Coding the Future, Reimagining K-12 Education in an AI-Driven World. And I always start most of, or I guess all of my talks with just the one main message that I'd like to get across to folks, so that if you walk away with just one thing, hopefully this is what you walk away with. And the big idea for this presentation is that the impacts that AI for software engineering is having right now should be telling us something about how we prepare our children for the future. Now, I've done this talk now a few times, and I think in the beginning it always kind of feels like, why are we talking about software engineering? You know, I'm here to talk about my children, or I'm here to talk about a specific field or whatnot. But I think through the presentation, you'll realize how, I mean, at the end of the day, almost most of the world at this point, at least the digital world, runs on software. And what's happening with software engineering right now is just totally changing the tech landscape. And it's going to have downstream effects with regards to definitely K-12 education, but so many other things about our livelihoods and about our careers. So I'll start first with a series of stories. So I grew up as a child of a Korean immigrant couple in Chicago back in the late 70s, early 80s. And this is a Gen AI generated picture of myself on Christmas morning crying. Now, why was I crying on Christmas morning? Because at that time, my family didn't have that much, wealth or money or anything like that. And so, it was just very rare for me to get anything from my parents that was, even like branded clothing or anything actually new. Everything was kind of a hand-me-down. And at that time in my life, a lot of my friends started to get the original Nintendo, the NES system. And I really wanted a Nintendo system. And so I'd ask my dad constantly, Dad, can you get me a Nintendo? Can you get me a Nintendo? And my dad, he at least when I was growing up, he wasn't really much of a communicative guy. Nowadays, he talks a lot more. So, he would just kind of acknowledge my request, but, being at least at that time, old school, first generation Korean parent, not many words and just acknowledge my request. And Christmas came and I see this present, up to the days of the days up to Christmas, I see this present under the tree and I'm thinking to myself, this is my chance. This is a new NES system that I'm going to get and it's going to be awesome. And, spoiler alert, it wasn't. So I open up this present and what do I see? I see a Radio Shack TRS-80. And my dad looks at me and he basically says, I don't remember the exact phrasing, but it was basically, Joe, this is called a computer. This is the future. You need to learn how to use this. And it was devastating. It was so devastating that I don't remember again the exact words, but I remember crying. I remember the feeling of being devastated. But what what he said was absolutely true. And what ended up happening was after I got, through bawling like this picture, I started to, what else could I do? I started to learn how to use this thing. And the Radio Shack TRS-80 was an amazing machine that was kind of the precursor to the Tandy 1000. Tandy 1000 was kind of, I think, one of the first real personal computers. And then, from there went to, the 286, 386, 486, if you guys, some of you all remember this progression of computing. And so at a very young age, I had access to a computer that most people didn't even know what a computer was at that time. And I started programming at a very young age. And this became a passion of mine. I became very good at programming up until 1997 is when I enrolled at the University of Illinois Urbana-Champaign. This is a picture of the Digital Computer Laboratory. This was the the building where the computer science degree was basically housed at that time. Now I think there's two new buildings now. But I got to college and basically I had a whole childhood from this Christmas crying day up into college programming. And so I was taking these CS courses at that time. And, back in those days, you couldn't program at least a CS assignment on a personal computer. You had to do all the programming in what was called Sun Microsystem Unix computers in the basement of this building. And so we would get a lecture and then we would get a homework assignment. They'd give you a whole week to do this homework assignment. And you'd have to sit in this basement. I'm not joking around. Basically, like every night, all night. At that time, you couldn't check your code every minute because you had to compile it and wait to see if it works. And so it was just a really frustrating and painstaking process to do computer programming at that time. And by the end of the week, it was just like you were, just in suspense to see if your homework assignment was going to work or not. Because basically the homework assignment was like either you got an A or you got an F. It either worked or it didn't work. And I'm sure there was like B's and D's and whatnot, but it was essentially like either it works or it doesn't work. Well, why do I tell this story? Because I tell the story because there was one week where the professor told us, you know what, we're going to give you 2 weeks to finish a homework assignment. And we were super excited because it was like, man, like finally we get more time. But then he told us what the assignment was. And the assignment was you need to create a workable chess program. It's not like a grandmaster at chess, but it kind of will play the game according to the rules of chess. And that was just an insane assignment at that time. It took the full 2 weeks. Most people, I'm not joking around, dropped the course during that 2 weeks. And I distinctly remember I got it to work like right before it was due. After 2 weeks of basically, I felt like not sleeping, not eating, and just programming. All right, why do I tell these stories? Well, some months ago, I think this was like 4 to 5 months ago, whenever OpenAI released their newest model, O1 preview, that's the name of the new model. I asked it in one prompt, hey, can you create me Minesweeper, but make sure it's one file, make sure that I can play it from directly from the browser on my Mac, and make sure that it has all the different icons and features, or something like that. It was a pretty simple prompt. Within 10 seconds, it created a workable and playing Minesweeper. Then I asked it, make me Flappy Bird. And it told me Flappy Bird is copyrighted. I can't create that program, but I can create you Tappy Plane. Well, what's Tappy Plane? Tappy Plane is some open source version of Flappy Bird with different graphics so that you don't break copyright. And so I said, okay, create me Tappy Plane. And it thought for about 20, 30 seconds, or it processed. And then it created me a working Tappy Plane. And then I asked it, create me a working board of chess. And it created this. This is a literal screenshot of what it created. And it created this in about 1 to 2 minutes. Now, I start with these series of stories because I grew up, it started sad, crying on a Christmas day, as an excellent programmer. And by the time I got to undergrad, I was kind of one of the best, and it still took me 2 weeks up until the end to program a chess game. By the way, programming computer games is one of the hardest things to do in computer programming. There's just so many variables. I mean, you could just imagine. And ChatGPT O1 Preview, when I asked it to create me a game of chess or chess game that works, it's like 2 minutes, and it worked. Probably better than what I programmed in undergrad. So I'm going to go back to this big idea. The impacts that AI for software engineering is having right now should be telling us something about how we prepare our children for the future. And here's my outline for this talk. The changing landscape of software engineering. Secondly, the need for a pivot in K through 12 education. And third, preparing for career fluidity. So first, the changing landscape of software engineering. Okay, current state of software engineering education. So this is both in all these kind of coding programs in K through 12. So much of K through 12 now has become, coding has become incorporated into K through 12, which is crazy as to what's happening now. And this is still how computer science is taught at most schools, which is there's a teaching of specific languages like Java and Python and development environments, what are typically called IDEs, integrated development environments, which is basically here's how you set up your computer so that you can code Java, Python, or these languages correctly. And the emphasis is on syntax, which is you have to type the exact words the right way in the right way for this code to work. And then also an emphasis on coding practices, basically saying that, you should think about how much processing time a certain mathematical loop takes. And so you want to be able to minimize, it's called discrete mathematics. And so this is kind of how software engineering is taught from K through 12 up into, undergrad and beyond. But now I just explained AI can code. And by the way, when I created this presentation, this was months ago. Today, just last week, what was being unveiled with regards to AI's ability to do full stack software engineering, it is insane. I thought that 3 months ago, whenever I created this presentation, it was going to take 8 months to get to where we are like last week. And so it's just accelerating like crazy. Now, these stats are from a McKinsey report in 2023. These stats are obviously now outdated. These are low. But basically from that report that you see at the bottom of the slide, the reference there, approximately 20% of software engineering tasks could be automated with current AI technologies. That is way higher now. Developer productivity might increase by up to 30% due to AI assistance. Again, those numbers are low. Core engineering roles will evolve rather than be eliminated, focusing more on higher level design and decision making. Now, that's the opinion of McKinsey, and I hope that's true. But I just don't know if that's true. Why? This is a older article from September 19, 2024 in the Wall Street Journal. And it was interesting because I was hearing so many stories from my friends in Silicon Valley that were being laid off from their jobs, from the big tech companies. And, a lot of the rhetoric at that time, and probably maybe still today, is that during COVID, we hired too many people in tech. And so post-COVID, we just had to get leaner, especially as the economy is starting to have confusing signals. But the people that were getting laid off and that I knew, they were telling me more and more, hey, I don't think this is just a post-COVID thing. This is an AI thing. And so this article, it's a tech jobs have dried up and aren't coming back soon. And it says employment for software engineers has cooled as resources shift towards developing artificial intelligence. More and more, when I was talking about this, 3 months ago, or I'm sorry, when I was talking about this 3 months ago, people were saying this is not true. It's not because of AI. It was because of COVID. I'm telling you right now, again, that mindset has changed because just a week or two ago now, people are saying, okay, actually, this is because AI is taking over software engineering roles, or at least these tech companies are trying to use AI, and not just tech companies now, bigger companies are trying to use AI to take over software engineering. So the implications for future software engineers, and you have to understand how much of a seismic shift this is, because typically in Silicon Valley, the job title of full stack developer, which is that's not the only good job, but full stack developers are like these ninjas of software engineering, and they could command salaries, depending on how good they are, of hundreds of thousands of dollars. Above maybe even $500,000 in Silicon Valley because they're so good. And now, just because of this technology, people are being laid off. Can you imagine making 400 grand and then all of a sudden making zero because AI is able to do what you were, best known to do? So implications. if we do end up having the same amount of software engineers or more in the future, like McKinsey is saying, I'm assuming that they're going to shift from writing code, because you can't write better code than a lot of these AI, programs. You have to shift from writing code to designing systems and solving complex problems. There's probably going to need to be an increased focus on AI collaboration and oversight. What do I mean by that? It's not developers using AI. I think in the future, software engineers and many other people in other professions are going to collaborate with AI. AI, especially if it has some kind of robotic form or some kind of physical form, it's going to have you're going to have collaboration skills with AI, not using AI, but collaborating with AI. So, will we have the same amount or more of software engineers? I personally would not bet on it, because my question for you is, do we have more blacksmiths? I know that's a ridiculously naive and simplistic question in comparison to the Industrial Revolution, but I just want to throw that idea out there that Industrial Revolution didn't produce more artisanal blacksmiths, right? That things got productionized and so things got more efficient. And so now if there are blacksmiths, they do it as hobbies. Can you imagine in the future that we've got software engineers that are doing it more as a hobby rather than their profession? I think these are reasonable questions at this point, as AI is changing the landscape of software engineering. So therefore, we really need to be considering a pivot in K through 12 education. Why do I say that? Well, because first of all, we are directly teaching coding in K through 12. We have more and more over the past decade plus said that every kid needs to learn how to code. And you know what? I really was against that from the beginning, because I grew up coding and I remember how hard it was for people. I remember in CS undergrad, how many people were doing CS because they knew that that was what would get them the job, but they didn't really like CS. And a lot of them would get decimated in these courses compared to us that actually enjoyed coding. We, enjoyed being in the basement and doing these, coding exercises. And so in K through 12, we've kind of been forcing this into children, and now AI can do it better than, most professional experts, right? So even with regards to teaching coding in K through 12, we need to shift. Now, there's still going to be need for code. There's still going to be a need for automated systems. In fact, there's going to be more automated systems in the future. There's going to be more software in the future. But instead of syntax, where we teach students how to use specific commands and specific coding words, that we need to shift from syntax to problem solving. So as an example, instead of memorizing Python, which is a computer language, instead of memorizing Python syntax, which means, again, the words, the commands of Python, students solve logic puzzles or design algorithms, thinking about what does an ethical and good algorithm look like versus an algorithm that is destructive or hindering to societal progress, right? Also, understanding systems and algorithms better, right? So here's a curricula thought: is students learning about AI infrastructure and getting a conceptual understanding of how algorithms work. What's amazing to me is that we still live in a day and age where most people that are not computer scientists, they still have no idea how the internet works. They have no idea how their iPad or their phone works. They just use these things, which I think maybe on one hand that's okay, but on the other hand, these things are getting so complex, and the design of algorithms and the design of online infrastructure is specifically being designed in a way where there's very real, there's very real motives. And I'm not trying to say that there's evil motives or whatnot. I mean, maybe there's good or evil, whatever, but there's very real things that are being built into human intentions that are being built into the technology. And if we don't understand how the technology even works from a reasonable level, then we're just going to get dominated by these things. And so just thinking about, can we from a young age teach students how AI infrastructure works, how algorithms work? How about ethical considerations in technology? Again, this is all, instead of teaching kids how to code, let's teach them these kind of higher order things. So, for example, a case study: discuss the ethical implications of AI generated code, right? Instead of you developing the code, let's have AI generate the code, but then discuss the implications of some of this code, such as potential bias or security vulnerabilities. I mean, the list goes on. Cybersecurity is a whole nother, presentation. But how do we help students to understand these things? And just think about even what I'm putting on this slide right here. Does any K through 12 look like this right now? No, right? And so we need to be thinking about a pivot very quickly. What about balancing the STEM focus with holistic education? We've gotten so focused on STEM, or now sometimes they say STEAM, but we've basically told young people that, the only kind of valuable paths or jobs, and I know I'm kind of exaggerating here, but we're kind of signaling that you got to do STEM because that's what's going to make you money. Well, unfortunately, or maybe it's fortunately, I don't know, with regards to the progress of AI, a lot of this STEM stuff, I mean, AI does math way better than humans, right? And I know some people say Gen AI doesn't do math well. I'm talking about AI holistically, not just Gen AI, but even traditional AI, right? We need to think about, instead of a STEM focus, how about holistic educational focus? So what about building interdisciplinary approaches for our K through 12 education? So example, a project combining biology, computer science, and ethics to design an AI system for personalized medicine. Instead of just teaching medicine, let's bring together different domains. And we can do that at a young age because, again, the technology is going to advance so quickly with regards to creating programs and software and whatnot, that it'll empower these students to think about various fields holistically together. We're going to need to teach our students, and we're going to need to teach ourselves, human to AI collaboration skills. Again, I mean, I use a robot vacuum at my house, and it's basically a one-way kind of command. I tell my robot vacuum what to do. But we're going to live in a day and age where we're collaborating with the AI around us. And so we need to teach our students that from a young age. Students working, for example, as an activity on a group project where they delegate tasks between human team members and AI tools. I won't speak to this that much in this presentation, but there's a whole focus of Silicon Valley right now on what's called AI agents. These things are basically the next step towards AI becoming, in a sense, autonomous, in certain degrees. And we're going to collaborate with these AIs. And then, of course, data literacy and statistical thinking. I think we do a really bad job in this day and age, at least in American education, of teaching probabilities and statistics and understanding data, when the reality is most of the decisions that we make every day would benefit from having a better understanding of statistics and a better understanding of being able to think about data. So we should teach this early. For example, how about analyzing real world data sets to make predictions like forecasting renewable energy production based on weather patterns? I mean, this is something that's so complex, yet if you use AI to assist, you can do this maybe in elementary school, which is nuts, right? Because the technology can empower us to do greater things at younger ages. And I think we need to push towards that, which, by the way, I've been having a lot of conversations with superintendents in the Pittsburgh area, and I see a lot of openness and a lot of push to move this ahead. And so that gives me great hope, not just for Pittsburgh, but I think for broadly K through 12. So, one thing that I mentioned is, remember back in the day, we used to have things like home economics or even tech ed. So home economics, you would learn about cooking or nutrition or sewing, textiles. You would learn about household management, health and hygiene, consumer education. With tech ed, you'd learn how to fix a car or do woodworking or these kind of things. And that's kind of been, in a sense, phased out of most high schools because, now we do coding, right? Well, I think we need to come back to this because, what about, we still need to cook, we still need to have nutrition, we still, I think, still need textiles, right? But what about things like, instead of household management, digital household management? This is a random thought, but how many parents, I mean, maybe some of you that will watch, either watching this live or will watch the recording, how many of you understand what to do with your kids with regards to devices and the internet and how to prepare them for that world, social media, right? This doesn't get taught to parents even, and definitely doesn't get taught to students. And so we need to be thinking about digital household management. I try to do this with my own kids. To be honest, I try to do this with adults around me because there's such a lack of literacy of how data and the internet and algorithms work, because nobody taught us that. I just happened to be part of, the few people that kind of grew up doing graduate school degrees in this stuff, right? And it's not straightforward stuff, and you need to start learning it from a young age. Digital health and hygiene. How do you protect yourself? How do you, especially mentally, get stronger and tougher as algorithms are coming at you full force? Digital consumer education. How do you make wise, even just buying choices, right? When marketplaces online are basically, targeted to make you spend all the money that you can spend, right? And again, I'm not anti-business. I have a couple businesses, so I'm very pro business. But at the same time, these algorithms are powerful, and we need to be able to understand them and understand how to conduct ourselves in a way where the algorithms are not controlling us, but we're able to live amongst these algorithms, right? Again, living amongst AI and what is to come. So I talked about the changing landscape of software engineering. I talked about the need for a pivot in K through 12 education. And so I want to talk lastly about preparing for career fluidity. And this is about, this is for not only us as adults, but for our children to think about how, as AI is changing software engineering, and that is going to change. I mean, think about how much technology controls our world right now. It's going to change technology, the tech sector. It's going to change timelines. It's going to change how project groups are set up, or project teams are set up, for tech companies. There's going to be a lot of displacement of jobs. It's going to be a crazy period of transition over the next 5 to 10 years. And I don't know if it's going to be pretty, but what I do know is there's going to be a ton of change. And I also know that people are going to have to figure out different ways to attack their careers and different ways to think about, what does it mean to sustain yourself? What does it mean to grow yourself? And young people, the amount of young people that I'm meeting, undergrads that are graduating from college and that are freaked out and that are having a hard time finding jobs. I travel quite a bit, and half of my travels are for higher ed. And I talk to a lot of young people, and it's rough out there. So what do we need to do to prepare, or how should we be preparing right now? Well, the future of jobs, let's think about it. This is from the Future of Jobs Report 2023 from the World Economic Forum from April 30th, 2023. This is old. So it's, again, much bigger numbers now. But they say that by 2025, 85 million jobs may be displaced due to a shift in labor between humans and machines. Simultaneously, 97 million new roles may emerge that are more adapted to the new division of labor between humans, machines, and algorithms. 85 million jobs. I think that number is way low, right? But that's still about a third, between a third and a fourth of the US population. Now they're talking about the whole world, right? But I'm just talking about just the number of people here, jobs. That's a lot of jobs being displaced. And again, I think those numbers are low. The same report highlights that 50% of all employees, 50%, this is now globally, half of everybody will need reskilling by 2025 as adoption of technology increases. Is reskilling easy? No, it's not easy. It's a very simple concept to talk about. It is very, very hard for people to reskill. And so we need to be thinking about, if you're an adult and a parent, you'd be thinking about both yourself, but also thinking about your kids. So skills that we need to be teaching ourselves and our children. These are just some of my thoughts. Obviously, there's way more that we need to be thinking about. First, we need to learn how to learn again. I don't know if this is just because of the internet or I don't know what, but so many of us have forgotten how to learn, right? And I see this in adults, and I'm hoping that students are better, but I see how students interact with the internet and with social media and whatnot, and we're looking for quick knowledge rather than learning deeply about something. And learning deeply about something requires time. It requires reading. I think, it kind of freaks me out that less and less people that I meet read deeply. We need to learn how to learn. And this is not just so that you can, say that you like to read a lot of books and people are impressed. Who cares about that? What I'm talking about is, in the future, if these AI, tools have basically the access to the primary, or at least the surface level of knowledge from the internet, and it has all of it, then if that's the depth upon which we go, the technology is going to kill us every time, or it's going to beat us every time. So we have to have nuanced understanding that is better than these technologies. And how are we going to get that? You're going to get that by learning deeply beyond what is just available via the internet, because AI just pulls from the internet. We need to have critical thinking and analysis. This is, again, just kind of drawing upon what I was saying with regards to learning deeply. We need to be reading. We need to be learning. We need to be thinking critically. Our students need to be getting past social media clips. We need to be getting past social media clips. We need more creativity and innovation. The way that AI works is that it trains on current data. So it's not going to be able to come up with drastically new and different things. Now, I know some people in reinforcement learning may disagree with me, but that's an argument we can have. I think we can all agree, though, that novel data is the most important data for training AI. Why? Because AI can't easily create novel data. And so who can create novel data? Human beings. And so we need to focus on the things that make us inherently human, which is creativity, innovation, emotional intelligence, interpersonal skills. I have to be honest, I grew up as a computer nerd, and, at times I would love to over-index into not being that social or whatnot. But I've learned over the years, and I'm thankful to have learned over the years that, interacting with people and having emotional intelligence, empathy, these kind of things are really important. I think our young people are maybe losing that because they have so much digital interaction and they don't have real world interaction, or at least digital interaction is bots and all these things. And so we need to focus on emotional intelligence. And why do I say these are all kind of things that are typically thought about from the humanity side of things, the human side of things. Why? Because the tech is going to be able to do the STEM things way better than we can do it. And that doesn't mean that we don't do STEM anymore, but I'm just saying that most people, it's going to pay off to focus a bit more on these things than trying to get better at math than AI. Technological environment literacy. This is a phrase I just created. I don't know if it makes sense, but this is basically, for example, what I mentioned before, saying, how does the internet work? Do many of us understand how the internet works, right? Like literally, how does data get in, data go out? How is it hosted? All these things, because that fundamental understanding really helps you to think through the content and it helps you to make decisions. So I'm not going to go too deeply into this, but maybe this should be something that I go, in a further seminar much more deeply into. But also technology fluency. So this is different than the environment literacy. Environment literacy for me is understanding how algorithms work holistically, understanding how the internet works holistically, understanding what cloud computing is. Cloud computing is not a cloud, right? And cloud services are really complex. We need to understand those things, at least generally. But technology fluency across disciplines, this is more, even if you're a profession that in the past didn't use a lot of compute, like maybe, just thinking about like medicine or whatnot, like doctors or whatnot. I know that there's computers in a doctor's room, but eventually, just imagine how much more computerized the medical profession is going to get. And so future doctors and future healthcare professionals are going to need to have deep technical fluency, at least for their discipline. But I think we're going to need it across disciplines. And then the last one for this list, this one's kind of out of left field, but many people agree that have training in AI. Anything involving complex physical real world trades, at least right now, I'm thinking for the next 5 to 10 years, are kind of protected from the disruption of AI. What do I mean by that? Well, AI, it can do repetitive things really, really well. But what it's not good at is encountering something completely new each time and then being able to figure out what to do with it. So if you think about things like plumbing, or you think about handiwork, or you think about electrical work, what you're encountering is different every single time. And so it's really hard for AI to automate that. Now, AI is really good at robotically in a factory picking up, shipping containers and moving shipping containers, or, making a car, one piece at a time. It's really good at that. But complex physical real world trades, fixing an HVAC unit, but every HVAC unit is a little bit different. These things are going to be pretty resilient against AI for some time. And so this is another pitch that I give to parents with young children, is that, hey, I'm not saying don't go to college, although I think that's a consideration for the future, but it might be best to think about college plus teach them some real world physical skills, right? Because I think that's going to separate people, because we're going to need humans to do those trades for quite a while. So the big idea for this talk was the impacts that AI for software engineering is having right now should be telling us something about how we prepare our children for the future. And I hope that gave you a glimpse. I mean, this is meant to be a short kind of seminar and an update, but I hope that what I just spoke about gave you a glimpse as to why things are changing so quickly, or to tell you that things are changing so quickly in tech, and why we really need to be thinking about how that impacts us. My final story before, if there's any questions, we can take them, is this school in Texas. It's called Alpha School. And basically, I think they're doing well because they keep growing locations at this point. But when I first heard about this school a few months ago, basically they were saying that we are a school where there's no teachers, there's no trained teachers, which I think is actually, that's a bad idea. I think we need trained teachers. But the way that they go about it is these students come into school, and for 2 hours, they interact with Gen AI, I guess. And there's a adult supervisor that is not a trained teacher, but they're just kind of there to be a mentor, or at least just to be a supervisor, which again, I don't know why you wouldn't use a real teacher or somebody that's trained, but in any case, they do that for 2 hours. And then the rest of the time, however much, 4 to 6 or whatever, however many hours that they stay at school, they work on doing physical real world things where, for example, they could work on setting up a business. Like I saw one example of a video where some high schoolers literally set up an Airbnb and started like trying to run a business. Or they would build some kind of, structure using materials and wood and, saws and these kind of things. And I thought, there were so many thoughts that I had, which, by the way, this school charges $40,000 a year for tuition. And again, this is elementary school, or this is K through 12. So this is a K through 12 private school, 40 grand a year for tuition, obviously not accessible for most people. But some of the things that I thought were very interesting was that they understood the importance of not computer, right? That for whatever 4, 6, 8 hours, getting students to do real world things is going to be really important for the future, because the computer AI is going to take over a lot of things that can be automated that we can kind of consider white collar work today. Now, I don't like the fact that they don't have real teachers and that there's just this kind of, adult supervisor, just letting these students just go through Gen AI and traverse it. Gen AI is full of hallucinations. That's a whole nother topic of discussion. But I use this school as an example because it's doing really well. And I think that there's going to need to be a little more indexing towards something like this for a lot of K through 12 education. But again, I think there should be real trained teachers that are leading these efforts. But it just shows that we're in the beginning of all of this. And especially, I'm a parent of 3 kids, 3 young kids. I have a 10, 8, and 5-year-old. It's really important for us to be keeping track of what's happening right now with the progress of AI and how that's going to impact the future of our kids and even the reality of our own lives. Thank you so much. And I'm going to now shut down this share so that I can see if there's any questions. All right, well, I don't see any questions or any raised hands. So I'm going to end the stream unless there's any last minute thoughts or questions. But I appreciate the few that joined live. And then for all those that will see the recording, please feel free to ask questions via the comments of this recording. And I will be attending to those as quickly as I can. But happy late Thanksgiving. And I see. Oh, hello, Brian. Thanks for the chat. And I think we'll talk later. So happy holidays, everybody. And I'll talk to everybody soon. I'll end this stream. Thank you all.